Now that we've examined the structure, functionality, and key methods in Java StampedLock, we'll take a look at an example application that illustrates how to apply Java StampedLock in practice. We'll use an example that actually comes out of the StampedLock documentation. If you take a look at the StampedLock.html file at the Java website from Oracle, you see they have something called the point class, which illustrates how to program with StampedLock. We'll be walking through this example step by step. Point is a class that maintains two-dimensional points. It's got a pair of doubles for x and y, which corresponds to the state that must be protected by a stamped lock. And here we have the stamped lock itself that will do the protecting for fields x and y. We'll start by taking a look at applying Java StampedLock in writing mode. This example illustrates a method called move, which is designed to atomically move a point to a new location. We pass in x and y as the parameters where we want the point to move to. And the first thing that happens is we go ahead and acquire the write lock for writing. This, of course, is a pessimistic write, which means that only one thread at a time can be in the section of code we're about to examine. The next thing we do is we go ahead and atomically modify the state, adding delta x to x and delta y to y. Finally, we go ahead and release the lock, thereby allowing other readers or writers to proceed. Let's take a look at how we might apply Java StampedLocks in Optimistic Mode. This method is called distance from origin, and we'll use it to illustrate how to perform an optimistic read with a stamped lock. This method will only be checking to see what the distance from the origin is and returning a value. It won't be updating the state of the point class or point object at all. The first thing we do is we attempt to get a so-called observation stamp by calling the try optimistic read method on the stamped lock field. We'll then go ahead and, with that optimistic read method called, we'll go ahead and set local variables cur x and cur y to the fields x and y. And this is pretty typical. You typically read the fields and hold them in local variables for later use after validation. Keep in mind, of course, that try optimistic read will do this volatile read internally to the inside of the stamped lock in order to make sure we get fresh values of x and y. The next thing we'll do is we'll go ahead and we'll try to validate the stamp. And what that does is it checks to see if another thread acquired a write lock after the earlier call to try optimistic read. If we end up having a write lock that did occur, then validate will return false. So in that particular case, what we're going to do is block trying to acquire a read lock. So this is an actual pessimistic read lock. And now with that read lock held, we'll go ahead and do these pessimistic reads of x and y into cur x and cur y. And then we'll go ahead and release the read lock using our try finally convention to make sure that we always get this lock released, even though it's unlikely to ever have an exception in that critical section there. Note that if validated succeeded, in other words, if validate returned true, there's no lock to release. In any case, we go ahead and do the computation with cur x and cur y in order to compute the square root and therefore get the distance from the origin. The last approach we're going to show here illustrates applying conditional write, which uses the conversion methods. So what this is going to do is it's going to move a point only if it's current or currently at the origin. The way we're going to do this is we're going to first acquire a read lock, and then with that read lock held, we're going to check to see whether the values of x and y, which are the fields, are 0. This particular loop will only execute at most twice for reasons you'll see in just a second. We'll then go ahead and try to convert the read lock to a write lock. This is what's called basically lock upgrading. And what happens is try to convert write lock atomically releases the read lock and then reacquires the write lock if there are no other readers waiting at that point. If it was able to do this, if it didn't return 0, that meant we were able to do the lock upgrading successfully. in which case we go ahead and update X and update Y, assign the write stamp to the stamp local variable, and go ahead and break out of this loop. Conversely, if the conversion failed, for example, if there was another lock that had this as a write lock, then we're going to have to release the read lock and then block again until a write lock is finally acquired. So the call to write lock here may actually block until we're able to get exclusive access. Interestingly enough, the values of X and Y could change between the call to unlock read and the call to write lock. So therefore, we have to loop back around again and retest this condition because those fields may have changed and therefore may no longer be what we expect them to be. Assuming that they're back to X and Y as they were before, now with the lock, if it is in fact the case that X and Y are equal to 0, then we're going to call try to convert to write lock again. And now this conversion will succeed because the stamp is in fact a write lock since it was locked as a write lock below in the loop. When we're all done, we go ahead and finally release the appropriate lock, which could have been a read lock or could have been a write lock depending on what happened in the loop. In any case, we're finished, we release the lock, and away we go. So that's the end of the example code to illustrate the use of Java stamped locks.